Yeah. So if I say something, I'll also be live, right? They can hear me.
Yeah.
Okay.
So it's okay. You also be live. That's what Jai did. She was not connected on the video, but she was talking. Okay.
Yeah.
Yeah. Okay. So Sachin, if there are any questions, you can start saying. Welcome everyone. So this is our live session before your exam starts next month. And if you have any questions, I hope you are all following the lectures. I think 11th week has started now. If you have any specific questions, you can put it in the chat. How many students have joined? Any idea, Sachin?
It's showing 6 live. 6.
Yeah, you can put your questions. And I can take it up discussing those questions. Any questions?
No, no, not yet.
Whoever has joined, can you start putting chat?
Sorry. Okay.
So this course was mainly a first course in group theory because this has a lot of applications in many other physics related courses, and I hope you would have at least, by now it's 11th week. It's more or less almost coming to completion. There are totally 12 weeks lectures. I hope you're listening and following and submitting assignments. And the final exam will also, the content, the syllabus will be from all the 12 weeks. And please make sure that your assignment submission, everything is happening, and you take the exams with putting in all all these contents, review them, go through all of them, and participate so that you score well in the exam. If you have this live session is mainly if you have any specific questions, I'm available now and I can work it out for you. You can ask some of those questions. So I don't know how many of you are. I think there are 5 6 students who are already logged in to the YouTube channel. Maybe you can post some questions and we can take it up. So we are waiting for some of your questions. In the forum, there are no questions. It means probably that you're all following the lectures and working out assignments. So let us know. We are live now. My TA Sachin and IS are also joined here. They're also actively looking at the forum and answering the questions. Even if you don't have any questions right now before the exams, if you have any questions, you can post it on the forum, and TAs Sachin and IS will answer most of them, everything in fact, so that you are well armed to write the final exam. So no chat questions, Sachin?
No, no, no. It's showing 8 people live, but till now no one. No, there's no question.
They have any comments? You have any comments?
No.
Ma'am, there is a question which is not related to this course, I guess. So Pashupati Nath Datta is asking basic difference between quantum entanglement and quantum superposition, please. Regards.
Okay, so this entanglement issues are slightly different in the sense that, if you take two different systems, you combine them, okay, and then if you try to see whether I can separate and write that superposed state as a product of system 1 times system 2, it's still a superposed state in some sense, but it can be written as a product of system 1 multiplied with system 2. Okay. In that case, it is not entangled. Sometimes it happens that you will not be able to write such a superposed state as a product of state associated with system 1 multiplied with the state associated with system 2. It's not possible. Okay. So this is where the entanglement starts coming in, and many of these entanglement plays a very crucial role. Like Bell states, if you have come across in this maximally entangled, you can see that the state is so completely entangled that you cannot separate it into system 1 times system 2. Any measurement of system 1 will tell you the system 2 should fall into a specific state. Okay? So this is one thing which will happen in the case of completely entangled state, that those two system states cannot be independent. Okay? So this are captured. These entanglement features are captured in many of these. The quantum entanglement is a big ocean where they start talking about how much is that entanglement, and they play a very important role. Yeah,
Ma'am, maybe you can give the example of singlet state. That's a uh,
that's right, but then they will not know. These are group theory students, they will not know so much of quantum mechanics, so I'm just trying to say it in a simple way, unless they've done quantum mechanics. Like
I
if you had two electrons in up state,
yeah.
both
No,
electrons.
I'm saying because he's this quantum entanglement and quantum superposition. So I thought that he might be knowing this basic quantum mechanics.
Possible.
Yeah, yeah.
So you can have a system 1 as, let's take a spin half particle. Okay, uh, a times for 1 plus b times. Okay, and system 2 would be a times some a1 times, this is for 1, and b1 times 2. Okay, you can have a combination of these two systems, and I can call it as a two particle system. Okay. So this two particle system, I can write it as psi1 times psi2, where each system is a superposed state, superposition of up and down spins, system 1 and system 2, and then I can write the 1-2 system, combined system, as a product of the two systems. This is one way of writing. I could also have another state as if it is A up down, okay. So this is system 1 and system 2, system 2 and system 1, sorry, system 1 and system 2. This state, can you again write it like this? I'm trying to say that this state, let me call it as a tilde. This state, I cannot write it as psi tilde 1, psi tilde 2. So in that sense, this is an entangled state, whereas the state which I have written here as a superposed state of system 1 and superposed state of system 2, and the product of those two superposed states is again a superposed state, but this is unentangled, whereas this one will be entangled. I hope this clarifies his question. Is Bowser clear? The board is clear, Sachin and IS?
Yeah, I can see clear.
Okay. Any other question? Yeah. Last time also we did not have many students, and some students complained that they were not aware of this live session till the last minute. And did they face similar situation this time?
And there is another question
Yeah.
by Pashupatinath.
Yeah.
So he is asking that wave function may be called analogs to Newton's second law or not. Wave function can be called as analogous to Newton's second law or not, and why?
So it's nothing to the wave function is something similar to the wave nature of particles. Okay. So Newton's second law and all these are particles which you look at, not the wave nature. So this wave function should be analogs of your electromagnetic electric field, magnetic field, which has this wavy nature, right? Sine omega t, k dot x minus omega t. That kind of
Hmm.
a interpretation you should give for the position space vector.
Maybe the more correct way of saying this is this thing is that the Schrodinger equation might be an analog to Newton's second law, right?
Uh,
I mean the analog of Newton's second law, because the Schrodinger equation governs the dynamics of wave function, whereas the Newton's second law governs the dynamics of the particle in classical
I agree.
regime.
So, but this
Yeah,
is going to capture the wave nature, not the particle nature. Newton's
yeah,
equation
yeah, yeah,
captures
yeah.
the
I mean the
particle
quantum analog of the Newton's second law would be Schrodinger equation.
for the non-relativistic particle. Anyway, Newton's law is
Yeah,
also for non-relativistic particle. Yeah.
yeah, 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 yeah. So I think yeah.
Anything else?
Basically, it is the quantization of the Hamiltonian. So that way it might be similar.
Yeah, they won't know so much of they've not even done the proper first course in quantum mechanics 1 and 2. Taking them to quantization and field theory will confuse them. So I'm just trying to explain it in because he's asking about Newton's law and the wave function.
Yeah, 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 yeah. So I think if you know the wave function, you must be knowing the Schrodinger equation. That's why I
Yeah.
said, yeah, yeah.
Anything else?
Not yet.
Yeah, I remember last time they had even some questions on some things about the exam weightage and so on. Those are resolved, no, Sachin and IS?
Yeah, yeah, I think those are resolved.
They are asking a lot of questions in the forum.
Not much.
Okay.
Yeah,
Okay, maybe Omkar, we could sign out now if there are no questions. It's going to be 5:30. We have 4 minutes and then we can sign out. Yeah. Okay, we'll sign out now. Bye. 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 Bye, Sachin.